Hello and welcome to the Electrical Engineering Bootcamp. In this episode, I am going to go over a distribution guide to what pole to use. In the general sense, for both transmission and distribution, there are only two structures that we generally consider, and that is either towers or poles. There are also three major materials that you would see when you look at the electric system. Is either you would see steel, concrete, or wood structures. And these structures, either towers or poles, is how it is being chosen by what is the conductors, either the tension or sag it supports, the cost that it's allowed, weather conditions, and the type of terrain of which this structure is being deployed. If we look at transmission lines is mostly consists of steel poles and towers, and concrete or wood poles are usually only used for shorter spans and or have less tensions. In transmission lines, usually a lot of times steel towers are being used when you need really strong strength, such as when you have a huge tension that you need to work with, or with very, very long span. And that reliability is really a concern and not the cost. In that case, you would then use preferably a steel tower rather than poles. In the distribution system, on the other hand, the distribution lines is mostly supported by wooden poles with wooden crossarms due to its significantly lower cost than steel, and it also have the advantage of natural insulation qualities, which you won't find with steel structures. However, there are some odd occasions where you would still use steel or concrete structures. um, that would be for usually exceptionally long spans, such as river crossings or highway crossings, etc. For wooden poles, we used usually three pole types. The first one is cedar, because it is considered one of the most durable in North America. Its other advantages include its light, it's gradually tapered, and it's usually straight. However, though, one disadvantage is that cedar often comes with a lot of small knots, and small knots usually affects its overall strength when present. The second type of wood poles is chestnut. Chestnuts are extremely strong and durable, but tends to be crooked. Lastly, pine is usually free of knots, and it's straight, and it's strong as well. However, though, pine has a disadvantage that it's not really reliable as it's prone to rot. Cedar and chestnut, on the other hand, have a relatively slow rate of decay. Historically, some poles would get butt treatment, which is treating the portion of the pole that's below the ground line with preservative in order to prolong the pole life from the moldy growth due to soil. However, though, after using it for a short while, um, it is stopped due to environmental reasons. However, though, in recent times, pine has becoming more and more popular due to the advantage that I mentioned before, being free of knots, straight and strong, and also that there are other more advanced wood preserving methods, such as the introduction and use of laminated poles. Now, Lastly, let's look at the problems with the different infrastructures, the metal structures and the wood structures in particular. Metal structures have a strength advantage when it compared to wood. However, though, it is subject to rust and corrosions and needs to be maintained periodically. Wood infrastructure, on the other hand, are subject to wildlife and linemen's climbing equipment, particularly the climbing spikes, as well as weather. Now, to combat these problems, the wood infrastructures are inspected periodically, and when tested that it needs to be replaced, then it will be replaced. I hope you enjoy this episode in the Electrical Engineering Bootcamp. And if you wish to connect with me, I would be more than happy to show you more in the electrical engineering world. Um, for the latest news in the world of electrical engineering, please connect with me through Twitter, which my handle is at eebootcamp. And don't forget to subscribe to our YouTube channel to get the latest free training videos for you to have more knowledge about electrical engineering and the various industries that are in the electrical engineering world. Lastly, if you wish to connect with me on LinkedIn, please send me a link of your profile to eebootcamp at yahoo.com. And after I receive the link to your profile, I will send you a personal invite to connect in LinkedIn. Again, thank you for your time. Have a good one. Bye for now.